Hello, good evening, guys. This is your Dharmesh sir. Once again, we are going to discuss the next session of carbon and its compounds. Already we have started our topic carbon and its compounds, where we have seen the basics of carbon, what are the unique features of carbon we have seen. Now a small information about covalent bond. Covalent bonds are very strong bonds. We also discussed that there exists a covalent bond between carbon and carbon atom. So from this we can say that these bonds are very strong. The bond between a carbon and carbon atoms are very strong. So like carbon to carbon, carbon hydrogen or carbon oxygen, all these bonds are very strong. Now coming to our main topic, very important topic. It is like the life of carbon and its compounds, that is hydrocarbons. What are hydrocarbons? Hydrocarbons are those organic compounds that contain carbon and hydrogen. I'll repeat once again. Those organic compounds, so these are also organic compounds that contain only carbon and hydrogen. So we discussed earlier, carbon compounds or organic compounds may contain other elements like chlorine, bromine, but here hydrocarbons means these are the organic compounds that should contain only carbon and hydrogen, and hence it is named as hydrocarbons. Right. Coming to the detailed study of hydrocarbons, hydrocarbons are of two types. Guys, hydrocarbons are of two types. Saturated hydrocarbon, saturated hydrocarbon and unsaturated hydrocarbon. So hydrocarbons are of two types, guys, saturated hydrocarbon and unsaturated hydrocarbon. I will explain you in detail. What are saturated hydrocarbons? These are the compounds. Simply, these are the compounds means we can say that these are the hydrocarbons with a single covalent bond in between carbon atoms. So saturated hydrocarbons means, guys, these are the compounds, that is organic compounds with a single covalent bond between carbon atoms, means there should be a single bond between any carbon atoms. Let us say simply, in between any carbon atom there must be a single bond. Right? This is saturated hydrocarbon. Next, unsaturated hydrocarbon. These are the compounds with both double bond and triple bond in between carbon atoms. So here very important to know that bond will always be there between carbon atoms. So unsaturated hydrocarbons are again two types. Guys, here saturated hydrocarbons are alkanes. Let us study about alkanes in detail. Anes, alkanes. Alkanes means there will be a single bond between carbon atoms. So all saturated compounds with single bonds are alkanes. Here unsaturated hydrocarbons are again divided into two categories. They are alkenes and alkynes. So here from the last suffix, that is enes, ines and anes, these hydrocarbons are classified. So alkenes are the hydrocarbons with double bond between the carbon atoms. These alkenes contain double bond between the carbon atoms. And alkynes are also the unsaturated hydrocarbons which contain triple bond between the carbon atoms. Clear, guys? So hydrocarbons are of two types: saturated hydrocarbons, unsaturated hydrocarbons. Saturated hydrocarbons are those hydrocarbons which containing single bond between carbon atoms. Example, alkane. Unsaturated hydrocarbons contain both double bond and triple bond in between the carbon atoms. Unsaturated hydrocarbons are two types again. They are the alkenes and alkynes. Alkenes are the hydrocarbons, unsaturated hydrocarbons that contain double bond in between them, and alkynes are the unsaturated hydrocarbons which contain triple bond between carbon atoms. So here we must know the general formula. General formula: all alkanes must obey general formula CnH2n plus 2. So this is the general formula, guys, very important, where n is equals to 1, 2, 3, 4, so on values. So C represents carbon, H represents hydrogen, where n is equals to 1, 2, 3, 4, so on. It cannot be 0, right? Here alkenes are unsaturated hydrocarbons with general formula. Alkenes must obey the general formula CnH2n, and alkynes must obey the general formula CnH2n minus 2. So this is very important, guys. Alkanes general formula is CnH2n plus 2. Alkenes CnH2n, and alkynes are CnH2n minus 2, where n is equals to 1, 2, 3, 4, so on in all alkanes, alkenes and alkynes. So now let us study in detail about the name of the hydrocarbon, what is its structure, shortcut structure and formula in detail. So guys, now let us study about alkanes in detail, but before that we already have seen that carbon is a tetravalent, which means carbon must contain 4 covalent bonds between carbon atoms. This is very important for examination point of view. They may ask you for bits. So being a tetravalent, carbon must have 4 covalent bonds. So this you should remember. So alkanes means, I already told you, alkane means those are the saturated hydrocarbons with single bond between carbon and carbon atom, right? And it should obey what? It should obey the general formula CnH2n plus 2, and where n is equals to 1, 2, 3, so on. So before writing the structure, shortcut structure and formula, we should be very careful with these words, the words that start where n is equals to 1, the starting of the word should be meet. Since these are alkanes, we should end with ane. So n is equals to 1, methane. N is equals to 2, it is ethane. N is equals to 3, propane. N is equals to 4, butane. Like N is equals to 5, pentane, hexane, heptane, octane, and nonane. Now, we see what is the structure of methane. N is equals to 1 now. So here N is equals to 1 for number of carbons, not for number of hydrogens. So I will take carbon as 1. We know that carbon being a tetravalent, it should have 4 hydrogens, 4 covalent bonds with hydrogens. So this is the structure of methane. Shortcut structure is very simple. 1C, 4 hydrogens, CH4. Formula is also CH4. Right. Next for ethane, N is equals to 2, means there should be 2 carbons present and there should be a single bond since this is a saturated hydrocarbon, and every carbon must have 4 covalent bonds. Already a single bond is present, 1, 2, 3 on either sides of the carbon. Here this single bond implies to both the carbon because we said that there should be a single bond between 2 carbon atoms. Therefore, hydrogen, hydrogen, and hydrogen. So, what is the shortcut structure? How many carbons? So, first carbon with how many hydrogens? 3 hydrogens. Second single bond, again 1 carbon. How many hydrogens? 3 hydrogens. So, this is the structure of ethane. And what is the formula? Number of carbons 1, 2, 2, and hydrogens are 6. So C2H6 is the formula for ethane. Similarly, we will do for propane, guys. So propane N is equals to 3, means number of carbons are 3. There should be single bond between carbon atoms and carbon must have 4 covalent bonds as we discussed. This is a very simple rule. Here only 2, already 2 are present between this carbon. So 2 plus 2, 4, 4 covalent bonds. It has obeyed 4 covalent bonds, and this is the structure of propane. So this is the structure of propane. So I will write the shortcut structure. First carbon with 3 hydrogens, CH3, single bond is there. Again carbon, 2 hydrogens, CH2, again single bond, carbon, 1, 2, 3, 3 hydrogens. So, what is the formula? Number of carbons are 3. Hydrogens 3 plus 2, 5, 5 plus 3, that is 8. Right? So, let us see if the formula is obeying its general formula or not. That is, I will try for propane. Propane means N is equals to 3. General formula is CnH2n plus 2. In the place of N, if I write 3, C3, H2 into 3 plus 2, C3, 6, 2, 3 the 6 plus 2, 8, C3H8 is the formula for propane. So we got C3H8. Therefore, it obeyed its general formula, that is alkane's general formula, CnH2n plus 2. So I hope this is very, very clear to you. So you need to be very attentive while discussing the structures because structures are very, very important. They may ask you in the examination to write the structures of alkanes, alkenes and alkanes in the examination. So as a homework, I am assigning you to write remaining from butane to nonane. Similarly, just you take the same name, its structure, shortcut structure and formula. Clear? So guys, we studied about structures, formulas, shortcut structures of alkanes. Now we will study in detail about unsaturated hydrocarbons. So unsaturated hydrocarbons must contain either double bond or triple bond in between carbon atoms. So in unsaturated hydrocarbons, first let us discuss about alkenes. So I already told you alkenes are the unsaturated hydrocarbons with a double bond in between them. So in between carbon atoms there should be double bond, right? And it should obey the general formula CnH2n, where as usual n is equals to 1, 2, 3, so on. So we'll write as it is once again. So you know very well, as I told you, we will be writing name, structure, shortcut structure, and the formula. So here you must remember one thing, guys. There should be a double bond between carbon atoms. Means between carbon atoms means there must be two carbon atoms. Where if n is equals to 1 means there will be only one carbon, and therefore what is not possible here? Methane is not possible. So you will not have the structure for methane. So it should start from ethene, where n is equals to 2, ethene. I told you there must be two carbons. In between two carbons there should be a double bond. So therefore this guy is not possible. Methane is not possible. So we'll start with n is equals to 2, that is ethene. Here I will ethene n is equals to 2 now, so there should be two carbons, right? And what should be there? There should be double bond, since this is unsaturated, and in unsaturated hydrocarbon we are discussing alkenes. So as you know very well, there must be four covalent bonds with carbon. So 1, 2, 1, 2. 1, 2, 3, 4. 1, 2, 3, 4. So this is the structure of ethene. So how we will write shortcut structure? Carbon with how many hydrogens? 2 hydrogens. And what is the bond present between? Double bond and carbon, again 2 hydrogens. So this is the shortcut structure of ethene. And coming to the formula, how many carbons are there? 2 carbons, hydrogens, 4 hydrogens. So ethene formula is C2H4. Very simple. You just focus on logic. N is equals to 3. N is equals to 3 means the starting word is prop and it becomes propene. So how many carbons should be there? 3 carbons. 1, 2, 3. Here it is very important to remember, guys. There must be a double bond only between any of the compound. Either you can write a double bond between these two carbons, or you can write a double bond between these two carbons. So one must be a double bond. So I will write a double bond here and remaining single bond. So this is how we will do. So our rule is there must be a double bond between any of the carbon and carbon. So here already 1, 2 are present. This is 3. Let us do here 1, 2, 3 and 4. 4 hydrogens, 1, 2, 3, 1 hydrogen, and here 1 hydrogen. You can write anywhere. You can write this hydrogens even down, no problem. This is also down, no problem, anywhere. But the structure should be very clear. So one double bond which should satisfy alkene rule, that is there should be a double bond between carbon and carbon, remaining single bonds. So carbon must have tetravalency. So 1, 2, 3 single bond, totally 4. 1, 2, 3, 4. 1, 2, 3, 4. So right now shortcut structure, first carbon 1, 2, 3 hydrogens, that is H3, and after single bond, here one carbon and how many hydrogens? One hydrogen, and double bond and carbon. Already two bonds are there, therefore this becomes CH2. So what is the formula? Formula is number of carbons C3, 3, 4, 5, 6. C3H6 is the formula for propane. Now let us do for last, that is N is equals to 4, that is but is the starting word, and the name of that hydrocarbon, unsaturated hydrocarbon, is butene. There should be four carbons. I told you one must be the double bond. As per the rule, one must be the double bond. So remaining single bonds. So here it is very simple. Hydrogen, hydrogen, here hydrogen. 1, 2, 3, 4, finished. 1, 2, 3, 4 hydrogens are completed. 1, 2, 3, and I'll write one hydrogen 4. Already 1, 2 is there. So 1, 1. So this is the structure of butene, and the shortcut structure. First carbon have 3 hydrogens, CH3. Second carbon has 2 hydrogens, CH2. Third carbon, 1 hydrogen, that is CH, double bond. Last carbon, 2 hydrogen. So this is the shortcut structure of butene. And what is the formula? It is C4, because number of carbons are 4. 3 plus 2, 5, 6, 6 plus 2, 8. C4H8 is the formula. Let us see whether it obeys the general formula rule or not. That is, general formula is equals to CnH2n. I want to check it for butene. Butene N is equals to 4. C4H2 into 4. C4 2 into 4 is 8. So C4H8 is the formula. So we got C4H8. So this is how alkenes structure should be derived, shortcut structure should be derived, and hence we will get the formula from the structure. Right guys, we have seen so far about the names of saturated hydrocarbons, that is alkanes, and also unsaturated hydrocarbon, alkenes. Now we are going to learn more about alkynes. So what are alkynes? Alkynes are the unsaturated hydrocarbons with triple bond between carbon atoms. Very simple. So this should contain triple bond between carbon atoms, and its general formula, it must obey its general formula, CnH2n minus 2, as usual, where n is equals to 1, 2, 3, so on, right? So as I said, here there should be 3 bonds present. Triple bond must be present in between carbon atoms. Here methane is not possible. What is not possible? When n is equals to 1, methane is not possible. So we will start from n is equals to 2. That is ethane. So ethane, there should be, ethane is otherwise called acetylene. The other name of ethane is acetylene. So carbon should contain triple bond between. So as per our alkyne rule, it should obey. There must be triple bond between carbon. Already 3 are completed. So one hydrogen. So this is the structure of ethane or acetylene. So shortcut structure. First carbon, 1 hydrogen. Triple bond is there in between. Second carbon, 1 hydrogen. So what is the formula? C2, number of carbons are 2, hydrogens are also 2. So actually this concept is very easy. Only thing is, you should observe how I am approaching the concept, and if you follow as it is, writing structures will become so easy. Where n is equals to 3, now it is propyne. I will write 3 carbons, As I told you while writing alkynes, there must be alkenes, there must be a double bond between any carbon. Here alkynes, no, there should be a triple bond between any carbon. You can write here also, no problem. So already triple bond is completed and one carbon. Now, as per the rule, carbon should have a tetravalency. So hydrogen, 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 4 completed. Here 3 plus 1, 4 is already completed. For this carbon, already 3 are there. So you can write anywhere, anywhere you can write. So this is the structure of propane. Now I will write carbon with 3 hydrogens, that is CH3. Next single bond, carbon, no hydrogens associated to this carbon, triple bond, carbon and one hydrogen. So this is the shortcut structure of propane. Formula: number of carbons 3, hydrogens 3 plus 1. C3H4 is the formula for propane. Now I will do it for butane. Butane means number of carbons should be 4. One triple bond is mandatory. So it should have tetravalency. 3 hydrogens, single bond, single bond. Here 1 hydrogen, 1, 2, 3, tetravalency 4. Already 3 are present. Here this is 1, 4 completed, and I will write 1 hydrogen. 1 plus 3, it is 4. This is the structure of butane. So coming to the shortcut structure, first carbon, it has 1, 2, 3, 3 hydrogens, CH3, single bond, 2 hydrogens, carbon, 2 hydrogens, again single bond, carbon, no hydrogens, triple bond, 1 carbon and hydrogen. So this is the shortcut structure for butane. So formula is number of carbons are 4, hydrogens 3 plus 2, 5, 5 plus 1, 6. C4H6 is the structure. Now let us check whether alkynes are obeying, these structures are obeying, this formula is obeying general formula or not. So general formula is CnH2n minus 2. I will check it for n is equals to 3, that is propane, whether our structure and formula is right or not. Let us see now. Propane, n is equals to 3, substitute in this formula, C3H2 into 3 minus 2. Therefore, C3H2 into 3, 6, 6 minus 2 is 4. C3H3H4 is the formula we have got. So, this is how alkanes, alkenes, alkynes structures are to be derived. So, your homework is to do remaining hydrocarbons, that is saturated and unsaturated, draw their structures, and completely you must have a clear cut idea about how these formulas are derived. So guys, our next topic is cyclic hydrocarbons, means here carbon atoms in this cyclic hydrocarbons are arranged in the form of rings. So simply, as we can consider cyclic hydrocarbons to be a closed figure. For example, I will take cyclopropane. So it should be like, it should be in the form of ring. This is very, very important. It should be in the form of ring. So I'll write, I should form a ring, you know, 1 carbon here, 1 carbon here, 1 carbon here. So it should be cyclopropane, means where propane, cyclopropane I will take, cyclopropane, which means propane means alkane, it should be single bond, right? So, and it should also satisfy tetravalency. Look at here, 1, 2, 3, 4. This carbon got 4. This carbon already 1, 2 are present. Hydrogen, hydrogen. 1, 2, 3, 4 completed. This carbon again having 1 and 2 bonds. So it should have remaining 2 hydrogen. So this is the structure of cyclopropane. I'll write the structure of cyclobutane. Cyclobutane. So it should be in the form of a ring. It should be like a closed figure. Carbon, 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 carbon. There should be a single bond between carbons since this is a alkane. So already 2 are present. One hydrogen here, one hydrogen here. Already 2 are present. Hydrogens. 2 bonds are present. So it should satisfy 4 tetravalent bonds. 4 completed. So here, so this is the structure for cyclobutane. Next it should be like cyclopentane. So cyclopentane, pent means 5. So it should be like carbon, 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 carbon and carbon. So 1, 2, 3, 4, 5. 5 carbons are completed. Pentane means alkane. There must be all single bonds between carbon. And you know very well, it should also follow the rule of tetravalency. 1, 2, 3, 4. This carbon should also have 4. 1, 2, 3. One more hydrogen. This should have 1, 2, 3, 4 satisfied. This is satisfied. Hydrogen. Somewhere you can write hydrogen here. So 1, 2, 3, 4. So this is the structure of cyclopentane. So cyclo means the carbon atoms should be arranged in the form of a ring. So this is a ring. This is a ring. This is a ring, closed ring, cyclic. This is a closed ring. And also it should satisfy the basic rules of carbon, that is the rule of tetravalency. Now there are another hydrocarbon called aromatic hydrocarbons. They are the aromatic hydrocarbons. What is the name? The name is aromatic or aromatic hydrocarbons. Hydrocarbons. So aroma, what is the meaning of aroma? Aroma means fragrance or smell. These hydrocarbons, they have a peculiar smell. They have a different smell. And example of aromatic hydrocarbon is benzene. So benzene is the example for aromatic hydrocarbon. So example is benzene and its formula is C6H6. Benzene means in, right? So how it will be arranged, I will tell you. So carbon, carbon, 3, 4, 5, 6. Single bond. And the structure of benzene is very simple. Guys, if you follow how I am doing, first give all single bonds in between the carbons. So first you give double bond, leave next carbon, again double bond, leave next carbon, again double bond. And it should also satisfy the rule of tetravalence, 1, 2, 3. 3 hydrogens or 3 bonds are completed, remaining with hydrogen. 3 are completed, hydrogen. 3 are completed, hydrogen. Here, hydrogen, hydrogen, hydrogen. So this is the structure of benzene. Structure of benzene. So this has come in examination for many times. So one must remember this structure of benzene, that is C6H6. So you will have a question in the examination like this. Draw the structure of aromatic hydrocarbon, which means you should do this in detail. You must write what is the formula of benzene, what is an example for aromatic hydrocarbon, that is benzene, and what is the property of that hydrocarbons. Like aromatic hydrocarbons, they will have a peculiar smell, means they will have a smell, and this is the structure. So aromatic hydrocarbon, benzene is also a cyclic hydrocarbon. So this is how you have to do. So guys, thanking you. So we'll see in the next session the remaining part of carbon and its compounds. Thanking you.